Assalamu alaikum YouTubers, welcome back to SLK Tools. Alright, here in this section again we'll be just designing a square tie column. Alright, and of course this is just RCD, reinforced concrete design, and remember this is continuation of the last lecture. In part 1 of this lecture, or in the last lecture, we have learned some different ACI 318 requirements for column design. And of course, we learned some additional requirements just for tie column. Also, we learned some additional requirements for spiral columns. I just recommend you to watch the part 1 of this lecture to know better about all these requirements, right? Because these requirements just helps us in design of column. Now here in this section, I'm just doing straightforward design. So are you ready? Yeah, of course you are ready. Here I just want to do an example, right? And of course, this example is taken from Sarhad University paper, all right? From, I think it was just the PAL 2016 exam. I know that. Alright, so we are just asked to design a square tie column supporting an axial dead load of 135 kip and an axial live load of 175 kip. And also AST is 2% of all gross cross-section area of column, and the strength of concrete is 4 KSI, and the steel strength is 60 KSI. So the example is, I think the terms are clear and straightforward. So I'll come straight into solutions. And of course, I'll design this column in 6 steps. My first steps will be just the determination of design load, alright, or the design axial load strength of this column. And in the next step, I'll just guess reinforcement ratio, alright. Remember, from ACI 318, it must be between 1 and 8%. Do you remember this guy? I have already explained this guy in part 1 of this lecture. Alright, and the third step will be just the calculation per section. Alright, it means the cross-section area of the column, so that we can just find the size of column, right? And in the step 4, I'll just calculate the amount of reinforcement using the same cross-section area, right? And this will help me just in calculation of number of main steel bars. All right, in this pipe step, I'll assume concrete cover. At least the best video is just 1.5 inches, 2 inches maybe. All right. And in the last step, I'll do some detailing check to check the column is okay or not. The column is according to codes or not. Alright, so I'll check my column or my design. So just keep these steps in your mind. Alright, I'll come just to our here into design. And my first approach is the design load. Remember, we have only two type loads, the dead load and the live load. So I can use a nice formula, 1.2 dead load plus 1.6 live load. This will give me the design load, right? PU. So 1.2, the dead load is just to our hair, 135 kip, plug this guy over here, plus 1.6, the live load is 175 kip, and also plug this guy over here. Do little mathematics with this guy, you can get PU equals 442 kip. And this is quite simple and straightforward. My next approach will be the size of column. Remember, this is a square tie column, right? It means all sides are equal to each other in length. Alright, and this is quite simple. And the AG, the gross cross-section area of this column, must be the multiplication of two sides, which are A cross A, right? So A cross A is just A square. Remember, from the part 1 of this lecture, we have learned a nice formula just for design load, which is of course just look like in this form, right? PU equals theta alpha 0.85 FC prime AG negative AST plus FY AST. Alright, and my design capacity will be alpha equals 0.80 and the theta equals 0.65, because this is just a tie square column, and the per tie square column according to ACI, we know about all these guys, the design capacity, and this is just little different for spiral column. All right, so if I plug and check in this equation, of course I can get AG from this equation, and the AG will help me just finding the size of this column. So plug and check in PU is just over here 442, plug this guy in this equation, equals, and the theta, where is theta? Of course it's here, 0.65 times alpha, which is 0.80 times 0.85 times FC prime is just 4 KSI times AG, which is unknown, negative AST, where is AST, it's of course 2% of gross cross-section area, so 0.02 AG, plus FY, it is just of course 60 KSI, the strength of steel, and AST is again 0.02 AG. Alright, do little mathematics just for AG, we can get from this guy equals 2.35664 AG. Alright, divide both sides by 2.3566, so we can get AG equals 187.555 square inches. Alright, because this is the area, right? That's why we take this guy as square inches. Now from this AG, of course I can just calculate the size of this column. Alright, just I'm doing this guy little over here, I'm making just a few rooms for myself. So just look at over here, AG is just a square. Alright, the side square, plug AG in this equation as 187.555 equals a square. Alright, I need a, not a square, so plug just a square root on this guy. Alright, and according to equations rules, whatever you do to one side, you must do that to another side. Alright, do let me take with this guy, you must get A equals 13.7 inches. I'll say use A equals 14 inches. Alright, and this is a square tie column, so 14 inches, 14 inches, 14, and again 14. So we found the size of our column, right, as 14 inches one side. So the gross cross-section area will be just 14 times 14 or 196 square inches. Now my next approach is to calculate the steel area, the required steel area, right, AST. What does AST represent? Just look at this section. These dots just represent the main bars, right? And the area covered by these main bars is just AST, area of steel. So I can use the same formula I did this guy for AG, right? And of course this is just explained in the part 1. I also recommend to watch part 1 again, right? You may think why he's just recommending again and again, because that's important to watch, right, before this lecture. So just look at over here. From this equation, I can just calculate for AST, alright, and this is our demand now, right? This is just required thing. So when you rearrange this equation for AST, you must get PU equal negative theta alpha 0.85 FC prime AG divided by this guy. Alright, plug and check in. You must, and again just recall these guys. This is the design capacity per square tie column. Alright, so AST equals PU. We already know this guy. Alright, we did a few minutes ago. And so plug PU over here 442 negative theta times alpha and 0.85 FC prime AG divided by theta alpha Fy again negative 0.85 times FC prime. Alright, do let the mathematics with this guy. You must get the area of steel just for this column 3.24 square inches. Yeah, this is good. And this will help me finding the number of bars just for this column, right? Now, what about the number of bars? This is my next approach, right? Per number of bars, let me just show you just a nice column from the book, right? Just look at over here. Let's jump to that book, right? Just wait a minute. Yeah, of course. Oh, sorry. This one, yeah, this one. And this is of course written by Nelson, Design of Concrete Structure, and this is 14 edition maybe. All right, let me just jump to that table. Yeah, this one, area of group of standard bars, because this is just a square tie column, right? So I can use per number of bars this table. Let me just take a screenshot of this table, right? So we can just work in our area, right? Just and just look at this section. The number of bars means these dots just represent the number of bars, and this is of course 8 in this section, right? Just let me take a section update guy. Right, so the number of main bars is my next approach, and of course as we did a few minutes ago, 3.24, and here you go, this one, this table. All right, this table now just help me picking a few options like 3.52, right, and 3.6, 4, 3.8 maybe. And these are just enough. All right, we are just giving a lecture now. Just look at over here. I can't use 3.8 because we have 3 bars, and according to ACI the requirements must be at least 4 number of bars, right, in a square column. This is just the least thing, right? So at least 4 number of bars must be provided in a square tie column. So I can't use this guy, right? Because this is just less than 4. All right. I don't want to use this 4 guy. These are 4 and number 9, right? I also ignore this guy. What about this one? This is good, I think. 3.5. I think this is good, right? Now, 8 numbers. Number of bars are 8, and it is of course number 6. So I will say this is good and use 8 just number 6, of course. All right, 8 means number of bars, and number 6 bar will be used, and this is good, I think. You can also just review this guy. All right, so I'll say main bars equals 8 number 6. How can I represent this guy over here? Just look at over here. We have 14 by 14, and these are just 8 bars, and they are of course number 6. My next thing is to select tie. What do you say? I'll say use number 3. But why number 3? Remember from the first lecture of this lecture, right? From part 1 of lecture, we have learned the minimum tie size. And remember, we'll use number 3 bar per longitudinal bars up to number 10, and of course number 4 bar per main bars up to larger than number 10, and our bar is just number 6, which is of course less than number 10, so I'll use number 3 as my tie, right? And this is quite simple, I think. Does it make sense? Of course. Alright, my next approach is just the tie spacing. You remember that guy from the requirements? We had only 3 things: 48 times diameter of tie, 16 times diameter of main bar, and the least dimension. So 48 times diameter of tie, plug and check in, 48 times diameter of tie, it is number 3, so 3 over 8. Alright, you can get 18 inches. Next thing is just 16 times diameter of main bar. So 16 times the diameter of main bar, it's just number 6. So 6 by 8, you can get 12 inches. And the least dimension of this column is of course 14 inches. So I can get the least of these 3 guys. And this is just the maximum tie spacing, right? These 3 guys will be the maximum tie spacing, right? So I will just take only 12 because this is the minimum of these 3 guys. Do you remember this from requirements? Yeah, I know. So I'll say use number 3 at the rate of 12 inches center to center, because 12 inches is the minimum of these three guys, right? And these three guys are the maximum tie spacing. I hope you remember them. All right. So I just got the stirrup. Sorry, the tie. The tie is just number 3 at a rate of 12 inches. Let me just assume the cover 1.5 inches. All right. And my next approach is to do little detailing check. Actually, we have done the design. Now the detailing check is just remaining. Let me draw my column again. 14 by 14. In the main bars. Also the stirrup, the tie, sorry, and the cover. And the first thing I want to check is the steel percentage. According to ACI 318, it must be from 1 to 8% of gross cross-section area. So you can say AST divided by AG. Plug and check in. AST is just of course 3.52. We have just taken this guy from that table. Divided by AG is just 14 by 14, say 1.96. So it's 0.017. If you multiply this guy with 100, you can get this guy in percentage, which is 1.8. And of course, this is greater than 1% and smaller than 8%. So we are okay. All right. And the next thing I want to check is the main bar spacing. And the maximum, according to ACI 318, the maximum spacing is just 6 inches. It must be just equal to 6 inches or less than 6 inches. So I'll say it's 14. The one side is 14 inches. I'll subtract 2 times concrete cover per 1 in another side. And the concrete cover is 1.56. I also want to subtract the tie, alright, 2 times tie bar diameter, because I just need the clean or clear concrete over here. So negative 2 times the diameter of tie bar, which is number 3. And I also want to subtract 3 bars from this guy, just per main bars, right? So negative 3 times 0.75 square inches. 0.75 inches is just the diameter of this main bar, which is also just known by number 6. Or if you divide the 6 by 8, you can get 0.75 inches. I'll divide this guy by 2 because we have 2 spans, right? When you plug and check in this, you must get 4.75 inches. And this is of course just less than 6 inches, right? So we are also okay over here. Yes, we have done it. Of course. And this is a good design, I think. What if it's just larger than 6 inches? Of course, then you can change the diameter or the number of bar. Also, you can change the cover from 1.5 to 2 inches maybe. Alright. So, good, I think. It's good. And again, yes. Alright. And just wait for the next lecture. We'll be just designing a circular reinforced concrete column, right? Just like this guy. Alright. So just nothing left. Thank you for watching and see you next time, and wassalam. And of course, remember me.